Hello, this video lecture is specifically on two-dimensional numeric array. Up till now we have seen how to declare, initialize and process the elements stored in one-dimensional array. In this lecture we will extend the concept to two-dimensional arrays. The C language allows you to declare and use two-dimensional arrays where we can have many number of rows and many number of columns. The two-dimensional arrays are mainly used to store and process the matrices. As you all know, the 2D array is organized as matrix or matrices, which can be represented as the collection of rows and columns. How to declare it? It is very similar to declaring a one-dimensional array. The syntax to declare two-dimensional array is as follows. We need to specify data type, then we need to specify name of the array, and in the two-dimensional array case, we need to use two pairs of square brackets. As you can see, in first pair of square bracket, we need to specify number of rows required, and in the second pair of square brackets, we need to specify number of columns required. For example, let us assume that we wanted to store and process a matrix whose size is 4 by 3. That means it consists of 4 rows and 3 columns. How to declare a two-dimensional array to perform this operation? It will be like this. I will use the data type int so that we will be able to store and process integer values. Then m is the name of the array. 4 in the first pair of square bracket indicates the number of rows, and 3 in the second pair of square brackets indicates number of columns. This is the way we can declare a two-dimensional array which will be able to store and process a 4 by 3 matrix. What will be the capacity of this array? That means how many values this array can store. The capacity of this array m will be equal to number of rows, that is 4, and number of columns, that is 3. That is 4 into 3 is equal to 12. This array can store 12 different values. What would be the size of this array in the memory? The size of array m can be calculated as equal to capacity into size of data type. Like in our case, the capacity is 12 into 2 bytes. Why 2 bytes? Because the size of integer data type is 2 bytes. Therefore, size of this array m in memory will be equal to 24 bytes. Hence, this command reserves a memory block of size 24 bytes. Array m can store 12 integer values. I hope you have understood this concept, that how to declare a two-dimensional array. Let's go ahead. There are 12 elements in this array, and all these 12 elements will have same name, that is m. Then how to differentiate between them? The compiler assigns unique identification number for each row as well as for each column as follows. So the elements will be differentiated from each other like this. As you can see in the diagram, this is the diagram of a two-dimensional array which consists of 1, 2, 3, 4 rows and 1, 2, 3 columns. So row index for the first row will be 0, second row 1, third row 2, next row 3. So row index by default starts with 0. Similarly, every column will also have unique identification number. Like first column will have unique identification number 0, second column will have unique identification number 1, and last column, third column, will have unique identification number 2. Then how the value 1 or element 1 will be differentiated from value 2? The value 1 will be identified by using array name, that is m, row index number in the first bracket, that is 0, and column index number in the second square bracket, that is 0. How to identify value 8? As you can see, the name of this particular element will be m, its row index is 2, and its column index is 1. So whenever we say m to 1, it will identify this location out of the 12 locations that we have declared or created. Similarly, when we say row index is 3, column index is 0, it will identify this location. So, to identify any location in a two-dimensional array, we require two indices. One is row index and other is column index. The number specified in the first pair of square bracket always indicates row index, and number specified in the second square bracket always indicates column index. Instead of integer values, here I can use variables also, like I can use I for a row index and I can use j for the column index. Right? Let's go ahead. We'll try and process this two-dimensional array. To process the array values present in this array, first we need to initialize it, because when we only declare it, all the elements will by default consist of garbage values. So we wanted to initialize it by using user input. The two-dimensional arrays are normally initialized row-wise. Means what? Let us consider variable I, which gives me row index, and variable j, which gives me column index. So when I and j are 0, 0, we are targeting or selecting a element m 0, 0. When it becomes 0, 1, we are selecting the element m 0, 1. Like this sequentially, we will keep the row index same till we do not initialize all the elements in that row, and then we will keep on changing column index numbers. So row index will remain 0, 0, 0, whereas column index will change as 0, 1, 2. After filling the first row, which consists of 3 elements, we will change row index number to 1. It also consists of 3 elements, so we will keep row index 1, 1, 1 for 3 next elements, and again we will change column index as 0, 1, 2. Similarly, for third row, we will keep the row index 2 and keep on changing column index as 0, 1, 2. Last row, that is fourth row, we will keep the row index 3 and keep on column index changing from 0 to 2. So if you observe the changes in I and j, you will find the I is changing less rapidly as compared to changes in j. That means we require, but both are changing, therefore we require two for loops. One for changing values of I and other for changing values of j. So which will be the outer for loop and which will be the inner for loop? Obviously the I for loop will be the outer because it is changing less rapidly, and the for loop of j will be inner for loop, because for one value of I, j should change 3 values, right? So it can be performed by using two for loops like this. So we can implement initialization of a two-dimensional array by using one for loop, that is I's for loop, which is outer for loop, and inside that we will use j's for loop for changing the column index. So I is selecting row and j is selecting column from that selected row, and then scanf command will accept a value. So first time when it will start, I will be 0, then j will be 0, and this element will be m 0, 0. So first value entered by the user will go into m 0, 0. Then it will go for j plus plus, so new value of j will be 1, and this statement becomes m 0, 1. So second value will go into the element m 0, 1. Then again it will iterate j plus plus, j becomes 2, so this becomes m 0, 2. So next or third value will go into m 0, 2. Likewise, when it becomes 3, 3 less than 3 will become false. So this for loop will be exited. It will go back into I plus plus in the for loop of I. So new value of I will be 1. Again j will be resetted to 0, then 1, then 2. So it will initialize second row. This is the way by which we can initialize a two-dimensional array, right? So this will be the structure of a two-dimensional array if I assume the size of this array is 4 by 4. So this is a this array consists of 4 rows and 4 columns. You can see in every element I have written row and column index in the square brackets to give you a clear idea that for this element what is the row index, what is the column index. This is the row index, column index for this element. Likewise, this is the row index, column index for this element. And also I have assumed the values of the elements also, and I am assuming that these values 1 2 3 4 5 6 7 8 9 8 7 6, these are entered by user. So this is how our two-dimensional array will look like after initialization from user. So we will initialize the matrix or two-dimensional array by taking user input, and after initializing it we need to process it. For example, we will see the first program where we will initialize the two-dimensional array, and we will write a program to find sum of all the elements of this two-dimensional array. So all the elements, that means I wanted to calculate sum of all the elements: 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, like this up to 2. So if I add all these elements, the sum comes to be equal to 80, that is 80. How to perform this operation? So let us go into the Turbo C and we will find out how to perform this operation. So I will take you to the Turbo C environment. I will just enlarge this Turbo C window, and now we will write our first program by using matrix or two-dimensional array, right? So let us declare a two-dimensional array int m of arbitrary large size, let's say 10 by 10. So maximum size that user can specify is 10 by 10. User can specify anything less than 10 by 10. I will take integer variables I and j as the row and column index numbers. I will take another integer variables r and c, where r will be used to specify how many number of rows user is interested in, and c is used for indicating or specifying how many number of columns user is interested in. I have created a matrix of size 10 by 10, but user may wanted to store a matrix of size 4 by 4. So in that case, first we should ask the user how many rows and columns you want. So user will specify number of rows required, number of columns required, that we will accept into the variables r and c. And we will take one more integer variable sum, where we will find out sum of all the elements. I hope you have understood all the variables that I have created. Then I will use CLR for clearing the previous screen output. Then the first dialog that I will have with the user is, I will ask the user about the size of matrix. I will say enter size of matrix. That means I am expecting two numbers from user. The first number is number of rows and second number is number of columns. Let us read these two inputs from the user by using scanf %d %d. The first number I will store into the variable r, second number I will store into the variable c. So now I know that out of the 10 by 10 size matrix, how many elements user wanted to utilize. Of course, if user utilizes only 2 by 2 part, then the remaining part is wastage, that we have reserved a memory but we are not utilizing it, and we have to live with this particular limitation because the C language supports the static array. So this is static array problem in C. In Java or in other languages we can have dynamic arrays also. Of course, in C also we can have dynamic arrays, but that can be implemented by using dynamic memory location. We will see that very soon, that how to initialize or how to declare array by using dynamic memory allocation. So right now you do not worry about it. We will only deal with the static array and we will live with the limitation just now we have understood. Now we will ask the user to enter the elements of the matrix. So for that again I will write printf to have a dialog with the user. I will ask the user enter elements of the matrix, right? And to read that element, as we have just now seen, we require two for loops. We write for I is equal to 0, then I less than r, because user wanted r number of rows, I plus plus. Then inside this for loop I will use another for loop for columns. Let's say j is equal to 0, j less than c, because user is interested in c number of columns, j plus plus. Inside this we need to write a scanf command. So we will write scanf %d address of m I j. So we will accept the elements like this. This is the procedure used to initialize a two-dimensional array by taking user input. So I will say this is input operation for 2D 2D array. So this part of the program is for taking input from user, two-dimensional array as an input from user. After taking input from user, I need to process that two-dimensional array. So here onwards, the second part, that is processing part, will start. What processing we wanted to do? We wanted to add all the elements of this array to find out sum of all. That means I have to visit every element and it's the value I wanted to add into variable whose name is sum. So basically I wanted to perform this operation. I wanted to perform sum is equal to sum plus m 0 0. Then I need to execute the expression again. Sum is equal to sum plus m 1 1. Oh, sorry, 0 1. That is second element. Like this, I should keep on adding all the elements. So what is changing in this expression? Only row index and column index is changing. And we know to visit every element, we can take I as a row index and j as a column index. So instead of writing these many expressions, we will write only one expression saying sum is equal to sum plus m, I and j. And we will use two for loops for changing values of I and j. So for changing values of I and j, we will do like this. We will write for I is equal to 0, I less than r, because there are r number of rows, I plus plus. Inside this for loop, I will write for, let's say, j is equal to 0, j less than c, j plus plus. Inside this for loop, I will write this expression. So now you can see values of I and j will keep on changing because of two for loops, and the new element or the next and next element will be selected and it will be added into sum. So by this time, when we come out of these two for loops, the sum is ready and we will be able to display it. Okay, so now we are in the third phase of the program. So this particular part of my program is dealing with the processing. Now we will write next part where we will perform output operation. So we will perform output. To perform output, I wanted to display the matrix as well as sum of all the elements. So in order to display the matrix, again I have to visit all the elements of that array, and we know to visit all the elements of that array, we need to write two for loops. But before that, I will write a printf command where I will say matrix is equal to, let's say, backslash n, and then I will write two for loops. For I is equal to 0, I less than r, I plus plus. Inside this, I will write for j is equal to 0, j less than c, j plus plus. So this is how we can visit every element. So these two for loops are important for matrix. These two for loops are mainly used to visit the all elements of the matrix. Now when we visit any element, what we wanted to do with that, we wanted to display it. To display it, I will write %d. I wanted to have a space between two consecutive elements, so I will write backslash t, and we will write name of the element, that is m ij. So if I do like this, all the elements will be displayed, but they will not be displayed in the matrix form. All the elements will be displayed in the same row, that means single row will be displayed, and the elements are separated by using space. What I wanted to do is, since this for loop is responsible for changing all the columns present in the selected row, when all the columns in the given row are over, before displaying next row, we should change the line in the output. So in order to change the line in the output before going to the next row, we need to insert one more command over here, that is printf, where I will just put backslash n. What is backslash n? You know, new line character. So after displaying all the columns in the selected row, that means after coming out of this for loop of j, what will get executed is this printf, which will change the line in the output, and then it will again enter into the for loop of I with the next value of I. That means we have selected next row. and then it will again display all the columns in that row, then again change the line, then next row display all the columns in that row, and then change the line. So this process will follow. This is a standard procedure for displaying the two-dimensional array in a matrix form. And of course at the end we need to display sum of all the elements. So I will write sum is equal to percentage d, and we will display the value of a variable sum, after which I will write get ch to freeze the output, and then that is all. That is the end of my program, right? So I hope you have understood the process that we have used. So again you can see the program consists of three major parts. One is input operation, then second is processing, and the third is output. So the structure of the program on arrays normally remains same. We need to divide the program into three parts: input, processing, and output. Let's compile this program. So when we will compile this, we will find that it doesn't consist of any error. We will run it to check the output. So when I run it, it will ask me enter size of a matrix. Let's say size of a matrix is 4 by 4. It will ask me enter the elements of matrix. Now here you need not have to worry about the structure of your input, because you can enter the elements in a single row or in the single column. They are automatically placed at the appropriate location because of row index number and column index number. Like I will enter the elements of the matrix like this: 1 2 3 4 5 6 7 8 9 8 7 6 5 4 3 2. So I have entered 16 elements, and then when I press enter, my program will perform addition of all of them. Then it will display this particular thing into matrix format, and below that it will display sum of all elements. Let's press enter. You can see this is first row, second row, third row, and final row displayed. So 4 by 4 matrix is displayed in the proper format, and then the sum of all elements 80 is also displayed. I hope you have understood this program, which is on two-dimensional array, right? Now let's go back in our presentation and let's go ahead. We wanted to perform other operations on a two-dimensional array. For example, instead of finding sum of all the elements, I wanted to find the sum of elements which are present in this diagonal. So I have highlighted the elements which are present at diagonal. So I don't wanted to add all of them. I wanted to add just 1, 6, 7, and 2. These are the diagonal elements. Let us say this is the first diagonal of the matrix, and this will be considered as second diagonal of the matrix. So now my question is, write a program to find sum of first diagonal elements of a matrix. What do you think? What we need to do? The problem is very simple. Instead of adding all, we should be able to select only those elements which are present in the first diagonal. So what is the thing, or what is the criteria these elements satisfies? Let's check. If I think, then you will find that row index and column index for this element is 0 0. For this element it is 1 1. For this element it is 2 2. For this element it is 3 3. Row index is always given by I, and column index is always given by j. So what is the criteria they satisfies? It's simple. That is I is equal to j. So instead of adding all the elements blindly, we should add only those elements which are satisfying the criteria I equal to j. Let's go back into our program and have this change. So right now we are having a program which will perform sum of all the elements, because we are not using any selection criteria while performing addition. Now we need to add a selection criteria, and we just now we find out, that is if I is equal to j, then only perform the addition, otherwise do not perform the addition. Do not consider that element for addition. So it is very simple. I need only one small change in the previous program. I need to add condition. If I is equal to j, then only add mij, otherwise do not add. Let us compile this change. We will run this. Again I will say it's a 4 by 4 matrix and elements are the same elements. Let's say these are the 16 elements. When I press enter, it will display the matrix. And what is the sum of first diagonal element? It is 1 plus 6, that is 7, plus 7, that is 14, plus 2, that is 16. We have calculated sum of first diagonal elements correctly. I hope you understood this change also. Let's go to the next problem. Now the problem is I wanted to find the sum of second diagonal elements. Can you think of solution for this particular problem? Again, you should be able to find out the condition which will select only these 4 elements out of the 16 elements. So this is your homework. This is your problem. Now, like I am able to select these 4. You should be able to select these 4 only. So try this on your own before coming to the next Zoom meeting. I have got one more problem for you. It is like this. I wanted to write a program to find the sum of boundary elements of the matrix. Boundary elements means these elements which I have highlighted, the elements which are present on the boundary of the matrix. Again, the problem is same. Instead of adding all the elements, we need to add only these elements. That means again we should have a selection criteria by which we can select only boundary elements out of the 16 elements, and we will ignore these 4. So you should be able to find out the selection criteria for this also, right? So I have given 2 homework questions to you. Let us try them seriously. Go through this video lecture, find out the solution that I have given for summation of first diagonal elements, as well as try and write the 2 other programs. In the next video lecture, we will be going through some more programs on matrix manipulation. Till that time, goodbye.